Hello everyone. So in the previous session we did started our project on bone fracture detection, and in this project I did explain about CNN, convolution neural network, which is a feature extraction technique, and that's one of the famous technique that is specially used for images to extract the features from them. Okay, so you are initially available with images. Images you are having in two folders. One is fracture folder where fracture images are kept. Another is non-fracture folder where non-fracture images were kept. Okay, this is what you are having. Images what we have seen is grayscale images because these are X-ray images. So X-ray images are grayscale images only. Fine. Now what we initiated in the previous lecture is, okay sir, you do one thing, you transform these images into particular size, let us say 224 comma 224. That will be the size of the image. Every image will be converted into this one. And sir, you are having a grayscale images, so kindly keep the color mode as 1. Okay, and it's also looking a balanced data initially. There is no much difference between fracture and non-fracture because you are doing classification, and in classification it is very much important to balance the data. So right now it's looking both the classes is balanced, so don't use any other technique initially. That's what we are thinking. And you can build an architecture because in deep learning you have to build up an architecture. So in architecture, I told we have also demonstrated few codes over the architecture I built based upon the CNN. So we have taken CNN layer with some filters 32, then 64, then 128, certain CNN layers, and the number of filters we have taken along with the pooling, where you mentioned max pooling to pooling is a feature reduction. Okay, it's a dimensionality reduction technique. So this is feature extraction, this is dimensionality reduction. Okay, I don't want irrelevant data in my features, so we can apply max pooling. Max, that means if you are having a matrix like this: 100, 10, 20, 30. If you do perform max pooling, so this particular value will be taken into the matrix. This value will be selected. So what we do in the convolution is we perform matrix multiplication between your image and the kernel, and we get a particular result. Reduced matrix we get because feature are extracted, so size of the matrix will be less. And then again we apply pooling on it, so further reduced. Okay, further reduction is being done. The way we are doing, the approach we are performing, na, that's to extract the features, to extract the relevant information from the image. Okay, so the architectures which I have demonstrated you in the previous class, what we found is we are not getting good scores. Okay, the good scores we struggled. So let me share my entire screen and show you the updated code for it. What I perform a change. Okay, let me show you a tab. Okay, code only. I think that is fine. Bone fracture detection. This is the code. Let me increase the size so it will be easier for you to see. So initially I imported my data, bone fracture data. Okay, you can see there are many images present in the data. So with cable, this is how it looks. Okay, fine. So I extracted all my data. Let me show you again. Here, till here. And then after getting the data, basic libraries I imported. Matplotlib, Seaborn, CV2, TensorFlow. That is what you have to do. Then you have to define the path where images are present. Mandatory. Mostly when I do work on images now, I do work on Kaggle because I know that the models which I will be using and the processing it will take now, I require GPU. That's the reason I do work on the Kaggle. For images now, I have to work here. So this is the path where your fractured images are present, non-fractured are present, validation directory and validation directory for non-fractured also. Okay, fine. All right. Then I did perform the counting of the images which are present in these directories. Okay, very simple. Just prepare the list of files which are present in a directory and calculate the length. That's very simple code. There is nothing hard and fast here. So just prepare a list and calculate the length. I did for train, fractured, non-fractured, validation and all these things I did. I printed. These are the values I'm getting. 4,480, 4,383. These are for training, fractured and non-fractured. Validation also 360 to 40. Then with the help of these labels and the countings which I have obtained, I made the bar plot, or I could say it's a count plot. So it's a count plot. Similarly, I made pie plot also to show the distribution in percentage. So this is pie plot. Okay, done. Then what I did is I displayed five images from these folders. So initially again make a list, then randomly select the images from these. Okay, randomly select the images from the list you have prepared. Okay, and then make a plot for them. Okay, so here I have made a plot that means showing the images from each and every folder. Grayscale, I am reading the grayscale images, so I am read grayscale. And here I am displaying the images from each category. Five images. Okay, it's up to you how much you want to display. Then what I did is now it's a tip for you. It's a suggestion for you. If you are writing, not writing, if you are listening, listen properly. See, our basic data science skills is to work on data frame. Okay, so accordingly, I can make a data frame of the images data where I can take the path where image is present and the label, whether it is fractured or not fractured. This is what you can do. It's a pro tip. Okay, it's a very important suggestion for you. So fractured images, okay, this is the directory where fractured images are present. This is the directory where non-fractured images are present in training. So I made a data frame fractured pd.data frame, make a file name and the label fractured. Then for not fractured also I made a data frame. Then I perform the concatenation of both of them. Concatenated. I concatenated both of them, and this is the file path. Okay, this is the file path where I have joined the image also in the existing Kaggle fractured and etc etc. I have joined the .jpeg also, like this. This is the file path. That means this is the entire file path, like this. Okay. This is the entire file path. Kaggle, input, bone fracture, detection, X-ray, archive, this up to this. And what this image stands for? Fractured. So in front of it, fractured will come in label. Okay, got it. So that's what I did. I prepared data frame for fractured, for not fractured, and I took the entire path along with the label. This is what you can see in DF data frame. See, Kaggle, input, bone, fracture, detection, X-ray, and vagara vagara. There are many things, and this is label fractured, and this is not fractured. So give the path, give the entire file path of the image, and give a label in front of it. That's what you have to do. So your data frame is prepared now. There are many things which we can simplify by creating a data frame. Now, again, you can make a counter plot. How many fractured, how many not fractured. You can make a pie plot. You can see whether it is balanced, unbalanced. You can apply a random sampling and you can balance your data. Because with data frame, the things are easy. And that's what I did. See, I see. Between fractured and not fractured there is not much gap, only 16 17 images were gap. Still I performed oversampling. Still I performed oversampling. Okay, and I balanced my data. Okay, see, I performed oversampling, and I resampled my data, balanced it. Okay, and I created a new data frame df resampled. And here you can see fractured 4480, not fractured 4480. Okay, got it. So with small difference also, I think let it be. Come on, balance your data. Now I am having the equal distribution of fractured and non-fractured. Okay, so this is very much helpful. By creating data frame, I am very much happy that okay, I can do this task. I imported the libraries time shuttle, that means it related to operating system and all these matplotlib, 10 traces, pre confusion matrix classification, TensorFlow, Keras, everything, deep learning, machine learning, basic libraries. I imported everything. convolution, 2D, pooling, wooling, and all these things I imported. Check. Okay, just print check. That's it. I have downloaded my data also, bone fracture CSV. You can download your data in CSV format also, no worries. Then what I did, I performed train test splitting here. So I am having DF sampled, which is a balanced data. DF resampled, it is balanced data. So I splitted this data into two parts where I kept 20%, 80% of the data for the training, and rest 20% I am taking in temp DF new. So I am splitting my initial data into two parts. Okay, if you want me to share the entire screen, this will be easier to understand. Again, listen carefully. Okay, see, you were having images in folder. We made data frame of it. How? I found the path, file path, and I put a label to it. This will made a data frame for fractured and for not fractured. Got it? Then because of some imbalancing, you use a random oversampling technique. And now it's all balanced. Then next is you want to divide this data frame into train, test, and validation. So what I did is, first I took this data frame and divided it into two parts, train and temp. Train I took 80%, temp I took 20%. Okay, so 80% of the data will be in the training, 20% will be in the temp. See here in the code. That's what I have mentioned. See in the code. Train DF new, temp DF new. So train DF new, I told that train size should be 80%. You can shuffle your data. Stratify equal to DF resampled label. Okay, I want equal proportion of fracture and non-fracture. तो स्ट्रेटिफाई करने का है मेरे को. ठीक है, तो वो जो डेटा जाएगा वो it will go in a balanced format. That is why stratify I am using here. Okay, got it. तो 80% मेरा ट्रेनिंग में आ गया, 20% मेरा टेम्प में गया. टेम्प फ्रॉम टेम्प. नाउ हियर, from temp you are taking 50% for the validation and 50% for the training. Here you can see test size 0.5. Okay, so from temp again you are taking test and validation data, both are 50%. 50. So I am initially available with 20% of the data, so 10% will go in testing and 10% will go in validation. So when I will be training my model with the training data, I can do validation with the valid data, and once my model got trained I can perform its testing. That's what I can do. ये थोड़ा सा बेसिक स्किल्स हैं, आपको आना चाहिए. नया तो कुछ नहीं बता रहा, लेकिन थोड़ी कलाकारी है बस. ओके, और कुछ नहीं. और ये छोटा सा कोड है, वेरी स्मॉल कोड. सो हाउ यू हैव टू डिवाइड योर डेटा विद द डेटा फ्रेम, कंसिडरिंग डेटा फ्रेम, ये करना है. अब उसके बाद प्री प्रोसेसिंग करी हमने. इमेज डेटा जनरेटर से क्या करा, बैच साइज 16 ये आप चेंज कर सकते हैं, इट्स अप टू यू. इमेज का साइज मुझे बढ़ा देना है क्योंकि छोटे स्मॉल साइज इमेजेस आई एम नॉट लुकिंग फॉरवर्ड टू वर्क, क्योंकि इफ आई डू अप्लाई द CNN तो इट विल रिड्यूस द साइज. तो कम से कम इतना बड़ा तो रखो. सो 224, दैट इज द साइज, विड्थ एंड द हाइट. चैनल वन यानी कि ये आपका कलर है, ग्रे स्केल है, तो चैनल वन। ओके, सो दैट विल बी द इमेज शेप। आप उसको नॉर्मलाइज करें divided by 125, and this is how you have to create a train generator data, valid generator data, and test generated data, test generation। ओके, ये आपको करना है। इन दिस पर्टिकुलर यू कैन परफॉर्म सम ऑगमेंटेशन, सम अदर टेक्निक्स ऑल्सो। अभी कुछ करा नहीं मैंने, आई जस्ट टुक माई ट्रेन डेटा, I created x colon file path, y column label, target is this size, I will convert my images into this particular size. The target is binary classification I'm doing. Color mode is grayscale at the moment. I'm shuffling my data. Batch size I'm taking as 16। सो ये कुछ ऑपरेशंस हैं जो आपको इमेज पर यू हैव टू अप्लाई। on training image you have to apply, you have to convert entire training image into this particular 224 224। you have to make them, okay, this is for binary classification। you can shuffle your data, mix up कर दो ताकि मॉडल को अपन कंफ्यूज कर दें। ओके, मॉडल को सीधा डेटा तो पकड़ाना नहीं है कभी भी, शफल करके दो। ओके, दैट्स व्हाट यू कैन डू। एंड कलर मोड इज ग्रे स्केल, अभी ये लेकर चल रहा हूँ। द सेम थिंग आई डिड फॉर वैलिड ऑल्सो, शफल कर दिया यहाँ पर भी, एवरीथिंग इज सेम। बस टेस्ट वाले को शफल नहीं करा मैंने। ओके, टेस्ट वाले को शफल नहीं करने का है ना, टेस्ट शफल कर दो गड़बड़ हो जाएगी। डोंट शफल टेस्ट, ओनली यू हैव टू शफल ट्रेनिंग डेटा एंड द वैलिड डेटा, दैट्स व्हाट यू कैन शफल। डोंट शफल टेस्ट, क्योंकि वंस माई मॉडल गॉट ट्रेन ना, देन आई विल चेक इट विद द टेस्ट डेटा। ठीक है, तो उसको शफल नहीं करने का। ओके, ठीक है, बात हो गई। देन आई चेक फॉर द जीपीयू, जीपीयू अवेलेबल है मेरे पास, तो मैंने एक आर्किटेक्चर बना दिया, ऐसे ही बना दिया। कन्वोल्यूशन 2D 32 फिल्टर 3x3 का साइज, रेलू एक्टिवेशन, पूलिंग लगा दिया। तो आपको कुछ आए चाहे ना आए कंप्यूटर विजन में, आपको ये टेक्निक थमा रहा हूं मैं अपने तरफ से। ठीक है, आई एम शेयरिंग यू एन अप्रोच टू यू, वेदर यू नो कंप्यूटर विजन, वेदर यू डोंट नो द कंप्यूटर विजन, you should be knowing what a layer do. What is the task? Okay, I need to extract the information from the image, relevant information. Okay, and I'm keep going on to extract the information. So here you can set, okay, 32 filters, 62 filter, 128 filter. Later on you can flat your data to convert it into 1D, and then add the dense layers here. I am adding one neuron because it's binary classification. The one neuron activation is sigmoid, binary classification। तो ये तो बेसिक से आपको वैसे ही पता होना चाहिए, बाइनरी क्लासिफिकेशन सिग्मॉइड होता है, और वन न्यूरॉन मुझे आउटर लेयर पे लेना पड़ेगा। यदि मल्टी क्लासिफिकेशन करते, इफ यू आर डूइंग मल्टी क्लासिफिकेशन, तो क्या चेंज करना पड़ता है? हियर यू हैव टू टेक सॉफ्ट मैक्स, एंड हियर यू हैव टू टेक नंबर ऑफ क्लासेस, 7 5 4 वॉट, बस ये चेंज रहता। और यहां पर कंपाइलेशन में भी चेंज हो जाता। लॉस में आप लिखते स्पार्स कैटेगरिकल क्रॉस एंट्रोपी इफ यू आर डूइंग मल्टी क्लासिफिकेशन, लेकिन बाइनरी क्लासिफिकेशन कर रहे हो तो यू आर टेकिंग बाइनरी क्रॉस एंट्रोपी। तो ये कुछ बेसिक्स है, ध्यान रखना। ओके, आर्किटेक्चर बन गया, कंपाइल हो गया, रन कर दिया। अर्ली स्टॉपिंग दे रहा हूं because in any case the losses will not get reduced if you are training your model and the loss is not getting reduced, तो भैया रुक जाओ, then stop, don't continue। if the losses are not getting reduced then stop, don't waste your time। ओके, तो ठीक है, अर्ली स्टॉपिंग कर देंगे, हालांकि मैंने सिर्फ 10 इटरेशंस तक ही चलाया, तो कोई टेंशन नहीं मेरे को। सो दिस इज माय ट्रेनिंग, हिस्ट्री, CNN मॉडल, फिट, ट्रेन, जनरेटर, न्यू, वैलिडेशन, ईपो 10, अर्ली स्टॉपिंग। वर्बोस मीन्स रिकॉर्ड रख रहा हूँ मैं फाइलों का, जो भी ट्रेनिंग हो रही है। लॉग लॉग रिकॉर्ड रख रहा हूँ, कोई ज़रूरी ही नहीं है, डिलीट भी कर दो। This is my training, and I was happy seeing the results. In 7 iterations, I got 99% accuracy training and 97% validation. तो भाई मैं बोल रहा हूँ यार, मुझे तो जो है एक्सरे है बोन फ्रैक्चर का, और विद दिस आर्किटेक्चर, वेरी सिंपल आर्किटेक्चर, 3 कन्वोल्यूशन लेयर में ही भाई खेल हो गया। 3 कन्वोल्यूशन लेयर में मुझे 99% की एक्यूरेसी मिल गई ट्रेनिंग पे, वैलिडेशन भी अच्छा दे रहा है, 97 पे तो वैलिडेट हो रहा है। तो ओवरफिटिंग यहां से तो नजर ही नहीं आ रही मेरे को, देर इज नो ओवरफिटिंग हियर। ट्रेनिंग 99, वैलिडेशन 97, कोई इशू नहीं है। चलो कोई बात नहीं। तो इसका हिस्ट्री प्लॉट बनाया, मैं और खुश हो गया। देखो भाई बढ़िया चल रहा है सब, ट्रेनिंग भी इंक्रीज हो रही है, वैलिडेशन भी इंक्रीज हो रहा है, एंड लॉसेस आर रिड्यूसिंग। Okay, the losses are getting reduced. हाँ, with a very simple. हाँ, Subhashish, yes, correct है. We need to check the confusion matrix. And yes, simple architecture and good pre-processing. ठीक है, देवेश कह रहा है कि सर काम अच्छा लगा, सिंपल आर्किटेक्चर है, प्री प्रोसेसिंग फाइन है, आपने चीज़ों को समझ लिया और ज़्यादा कॉम्प्लेक्सिटी नहीं करी आपने। लेकिन सुभाशीष भी जो कह रहे हैं सर कंफ्यूजन मैट्रिक्स देख लो सर, उसी से पता चलेगा, बिल्कुल सही कह रहे हैं सुभाशीष। जब मैं आगे बढ़ा तो मैंने अपने मॉडल को टेस्ट का प्रिडिक्शन लिया, उससे अपने मॉडल से आई परफॉर्म द प्रिडिक्शन। प्रिडिक्शन लेने के बाद जब क्लासिफिकेशन रिपोर्ट बनाया तो एक्यूरेसी भाई 50%, भाई वहां वैलिडेशन पे तो 90%, यहाँ पे 50%। इस बात को यू हैव टू वैलिडेट व्हेन यू विल रन माय कोड, है ना, यू हैव टू सी क्या ऐसा हो रहा है। ओवर फिटिंग केस, यस। So, though we are seeing during training and validation that scores are very high, 90%, there is nothing been like a feel cookie that model is overfitted. But when I tested my model on the data that is test, then there is an overfitting in the model. Only the test accuracy is 50%. Now I want you guys to again rerun the code and see what's at your end. You have to run my code only, nothing. I will share the link, you have to run my code only. Okay, and see. तो ये आर्किटेक्चर दिखने को अच्छा था, लेकिन अभी मुझे हियर आई एम गेटिंग ओवरफिटिंग। तो ये कंफ्यूजन मैट्रिक्स है, अभी आप देख सकते हैं कि मॉडल इज शोइंग कंफ्यूजन। ओके, देयर इज इशू विद द मॉडल। उसके बाद क्या हुआ, आई प्रोसीडेड अहेड, मैंने सोचा एक काम करते हैं। ऐसा तो नहीं कि आई एम टेकिंग द ग्रे स्केल इमेज एंड दैट इज द रीजन कि वो लफड़ा हो रहा है, तो आई आई चेंज द कलर मोड, RGB। दैट मीन्स आई विल बी कन्वर्टिंग द ग्रे स्केल इमेजेस इनटू कलर्ड इमेजेस, दैट्स व्हाट आई एम डूइंग। मैंने चेंज कर दिया उसे, मैंने क्या भाई, क्योंकि RGB में मेरे को फ्लेक्सिबिलिटी है। Why? Because your all the pre-trained models do work upon RGB color mode. वो ग्रे स्केल पे काम नहीं करते, वो एरर फेंक देंगे आपको। ओके, दे डू वर्क ऑन RGB कलर मोड पे काम करते हैं। तो मैंने सोचा एक काम करता हूँ यार, व्हाट शुड आई डू, आई डू कन्वर्ट। तो ऊपर वाला पूरा कोड ये वाला कॉपी पेस्ट करा एंड कलर मोड RGB कर दिया, रेड ग्रीन ब्लू। एंड एक चेंज और आएगा यहाँ पे, देयर इज वन मोर चेंज। हाँ, चेंज में, ओके ओके ओके, चेंज तो करना चाहिए था भाई। हाँ, ये रहा, इनपुट शेप शुड हैव टू बी 3। ठीक है, इट शुड बी 3, इनपुट शेप शुड बी 3, क्योंकि कलर चैनल 3 है ना। तो एक मुझे करेक्शन करना है, रहेगा यहाँ पे, ये चैनल 1 लिखा है, नाउ चैनल विल बिकम 3। खैर वो प्रॉब्लम इसलिए नहीं आई क्योंकि आई डिड इनपुट शेप हियर 3, वरना प्रॉब्लम आ जाती। सो आरजीबी में चैनल 3 हो जाता है, ग्रे स्केल में चैनल 1 होता है। कलर चैनल है वो, कलर मोड है 1, यहाँ 3। सो अगेन आई अगेन कंटिन्यूड विद द सेम आर्किटेक्चर। मैंने बोला यार सेम आर्किटेक्चर कंटिन्यू करते हैं, आरजीबी कलर में चेंज कर देते हैं और ट्राई करते हैं, लेट्स ट्राई विद द सेम थिंग बट विद आरजीबी। अगेन आई वॉज हैप्पी टू सी द रिजल्ट, 100% accuracy. You can see at ninth iteration I am getting 100% accuracy and validation is also 98। फिर भाई वो ओवरफिटिंग यहां तो नहीं दिखा रहा, नॉट शोइंग ओवरफिटिंग हियर। मैंने सोचा फिर,
Sir, I have a question.
या
Can
यस
I
सर,
ask a question?
यस यस प्लीज।
So the original images are already in grayscale, aren't they?
हाँ या ओरिजिनल ग्रे स्केल सर, यस।
So adding RGB is not going to add any information.
Well, adding RGB is not getting any information, but the point is, I want to use models ahead, pre-trained models ahead, which do perform on RGB scale, RGB color mode. You are saying that images are in grayscale, that means from 0 to 255. And if I change those colors into three, red, green, and blue, they will not add any information, additional
Right.
information. Okay. Changing the color, making a black and white color, making a black and white image into colorful image, it doesn't add any information. Sir,
Right.
just a general question to everyone. I am having a black and white image. Okay, this is my image. This is black and white image. If I make it to color image, now this is colored image. There is no difference, no information added. Do you think, sir? If I'm
The
converting
original image was
something,
acquired in black and white. There was
huh,
no each channel was
huh,
collapsed into black and white, into
huh,
grayscale. So you can't create unless it's pseudo color, you can't create more
okay,
information than what was originally acquired.
okay. That means you're saying the channels are fixed. If the image is grayscale, so it will remain grayscale. Doesn't matter. You change the mode of processing those images. I did change the mode of processing these images. You can see the architecture which I built, that is based upon three channel. So three channel means you will be having a blue channel matrix, you will be having green channel matrix, you will be having red channel matrix. That's what the channel means. Three channels you will be having, and these will be the matrix for them. And if I need to pass over, if I need to interpret my image over these channels, the question is, as you said, there is no change happening. How can we say that there is nothing changed? If I'm going to pass the image with these three channels, can we still say no change occurred? How? Every transformation, every selection which you do, every kind of operation which you perform, that brings a change. These three, blue, green, these are the channels. So I selected three channels now as my color mode. And I gave the image, now I changed 224, comma 3. So does it, this number is different from 224 2241? Are we not expecting any change? Any change? No. Sir, are you sure that we will not have any change? No additional information? No further operations been performed? I have made my entire work like with this three channel, like giving the image in this format. Input shape will be this. Input shape in this, that means okay, resolution, width and height is same, but the image will be three channel: red, green, and blue, not one channel. Three channel means okay, you are having three different matrices for these channels: red different, green different, blue different. So with the existing image, I am taking these three colors. Then I am feeding it to my model for feature extraction. Doesn't it brings any change? No, sir. What do you think? What about others? Yes, yes. If you put some value here to the input data, obviously there is a change, sir. I can't say, neither you can say that there is no change. Input shape 224241 is not equal to 224243. Doesn't matter you are having a grayscale images. Okay, but now the color mode is RGB. Here the color mode was grayscale. There is a change, sir. We can't say that no change happened. With this resolution of the image, I added R, G, B, three channels, not one channel. So definitely it will be going from this channel to get a matrix. Then you are performing this feature extraction. Okay, that's a good question, and that I decided to take this RGB. I trained my model, and you can see the training from. See, I took the same architecture. Previously, on the same architecture, I only went for how many EPOS? I went for 7 EPOS, 99% accuracy. This is the value. Now I went for how much? Till 9 EPOS, 100% accuracy. Validation 98. Okay, fine, doesn't matter. But when I perform the confusion matrix of it, still I am not been getting any positive response. It is 50% only. 49 previously it was 50. Huh, there is a balancing here in fractured non-fractured. These scores are balanced score, but overall accuracy is only 49%. That means still model is getting confused in fracture and non-fracture. Okay, then I thought, what should I do? I am available with many pre-trained models which I can utilize here. They are VGG 16, 19, Inception, Exception, ResNet, EfficientNet, MobileNet. There are many pre-trained models. I took some. I took some of the models. I took EfficientNet, ResNet, and Exception. Mobile, and see, it's not like that randomly you are going to choose any of the model. MobileNet is an architecture which is used for this kind of classification, image classification, but that is for edge devices. That means mobile devices. On mobile devices, you can use this algorithm to perform classification. Similarly, we do have some perspective for these algorithms. Okay, I took efficient net, this architecture, pre-trained model. Efficient net, we are having B0, B1, B2, B3, B4, B5, B6, B7 वर्जन है इसके भी. देर आर मेनी वर्जन ऑफ एफिशिएंट नेट. अभी मैं आपको समझाऊंगा तो बहुत टाइम हो जाएगा, बहुत, इट विल टेक अ लॉट ऑफ टाइम टू एक्सप्लेन ईच एंड एवरी कंप्यूटर विजन आर्किटेक्चर. जस्ट आई एम टेकिंग अ नेम एफिशिएंट नेट. अच्छा, ये जितना भी प्री ट्रेन मॉडल्स है ना, ये इमेजनेट पर है, इमेजनेट डेटाबेस पर. इमेजनेट इज अ बेंचमार्क डेटा सेट. I already told, I think previously, ImageNet is a benchmark data set where these models are trained, where these architectures are trained. Yeah, whatever be the architectures I told, na, they all are trained over benchmark dataset ImageNet, which is having millions of images of different classes, different category. तो ये सब ट्रेंड है उस पर. तो इनके वेट्स हैं, इन्हीं के वेट में डाउनलोड कर लूंगा. आई विल डाउनलोड द ट्रेन वेट्स. एक बात और है, कुछ लोग क्वेश्चन भी करते हैं, सर इमेज नेट में मेडिकल डेटा तो था ही नहीं. मेडिकल डेटा इज नॉट प्रेजेंट इन इमेज नेट. इन इमेज नेट वी आर हैविंग पर्सन, वी आर हैविंग some animals, cat, dog, we are having any other objects, but sir medical data तो था ही नहीं. And you are right now utilizing this pre-trained model on medical data, sir. तो विल इट वर्क? द क्वेश्चन इज विल इट वर्क? करेगा ये? देखिए क्या है, तो ये घुमाने वाली बात है फिर. सी आई हियर आई एम कंसिडरिंग हियर अ मॉडल which understand images, which understand images. Understand images means okay, which has been trained over the images. अब वो मेरे पास किसी की भी हो, पर्सन की हो, डॉग, कैट, हॉर्स, any other object, I do have an image. There are many classes in thousands of category present in the ImageNet data set. Millions of images are present in the ImageNet data set. तो वो डेटा, ये मेरा मॉडल इमेज के बारे में जानता तो है. ओके, इट अंडरस्टैंड. इट डजेंट मैटर अभी मेडिकल की नहीं है उसके पास, बट वो इमेज को जानता है. आई कैन टेक इट्स वेट्स, आई विल टेक द weight, and I can add a few layers in front of it, that is called as transfer learning. I can take the weights rather than I do develop a model from my side. This is what I did. This is the model which I developed from my side, CNN model. It gave me good score also over training and the validation, लेकिन वो टेस्टिंग में फेल हो गया, तो भाई मैं फंस गया. देन आई थॉट कि एक काम करते हैं, लेट्स टेक अ प्री ट्रेन मॉडल. आई टुक एफिशिएंट नेट. You can take VGG, you can take Inception. Okay, you can take it. Inception V3 है, V4 है. Okay, you can take. So I took efficient net, this model. इसका जो this efficient net, जो भी आप लेंगे ट्रांसफर लर्निंग के लिए, efficient net, this architecture, you just take the weights of it. Just take the weights and add few layers ahead. इतने मॉडल को मुझे फ्रीज करना है. आई विल फ्रीज दिस मॉडल. इसको ट्रेन नहीं करूंगा मैं. आई विल नॉट ट्रेन इट. द बेस लेयर्स, द बेस मॉडल विल रिमेन अनट्रेन्ड. इसको ट्रेन नहीं करना मेरे को, भारी पड़ जाएगा नहीं तो. बिकॉज दीज आर हैवी आर्किटेक्चर्स, एंड ट्रेनिंग ईच एंड एवरी न्यूरॉन इन दिस आर्किटेक्चर विल टेक अ टाइम. सो जस्ट फ्रीज इट and take the weights from the layers, to the layers, add few layers. जो मैंने कर दिया यहाँ पे. I added okay, I added global average pooling, that is to reduce the spatial dimension. I added dense layer, dropout entrance, ये to reduce the overfitting. So that's what I added, these layers only, 4 layers. ये कर दिया बस मैंने. एंड देन आई गेव माई डेटा फॉर द ट्रेनिंग. तो भाई ये तो स्ट्रगल कर रहा है. You can see accuracy is 49. हाँ, training and the validation both are less, but competition में है. Training and validation are less, but they are in like competition. 40, 48, 50, 49, 50, 49, 50, 51, 50 and 49, 50. That means कोई ज़्यादा अंतर नहीं है. But यहाँ से वी आर नॉट गेटिंग अ स्कोप दैट इट मे रीच टू 90 प्लस. ऐसा स्कोप नज़र नहीं आया मुझे. देन आई ड्रॉप आइडिया ऑफ यूजिंग B0 मॉडल एंड आई प्रोसीडेड अहेड विद एफिशिएंट B3. मैंने आपको पहले ही बोल दिया एफिशिएंट नेट के वर्जन है. B0, B1, B2, B3, B4, B5, B6, B7, इतना तो मेरे को पता है. सो B7 हैवी मॉडल है, इन सब से बड़ा है, बिग. सो आई टुक इंटरमीडिएट एफिशिएंट B3. एक और नई चीज ऐड करिए. देर इज वन मोर न्यू थिंग आई एडेड. गॉसियन नॉइस. देखिए क्या हो रहा है, अभी नॉइस पे भी काम हो रहा है काफी ज्यादा. ओके, नाउ in LLMs also, large language models also, work on noise in research is going on. हो रहा है. That means we use attention mechanism. तो अटेंशन मैकेनिज्म में जिन्होंने मुझसे पढ़ा है, दोज हु हैव लर्न फ्रॉम मी, उनको पता है कि सर द फॉर्मूला फॉर अटेंशन मैकेनिज्म इज Q डॉट के ट्रांसपोज डिवाइडेड बाय स्क्वायर रूट ऑफ डी का सर शॉर्ट मैक्स. लेकिन साथ में वो डिफरेंशिएशन भी कर रहे हैं. डिफरेंशिएशन, इस इक्वेशन को मॉडिफाई करा है उन्होंने. सो आई वॉज लुकिंग वन पेपर डिफरेंशियल ट्रांसफॉर्मर, और वहां ये जो फंडा है ना वो नॉइस के रिडक्शन करने का है. नॉइस रिडक्शन अनवांटेड. आई डोंट वांट द रिजल्ट्स विच आर अनवांटेड. अनवांटेड वर्ड्स, अनवांटेड टर्मिनोलॉजीज. तो मैंने सोचा यार इतना प्री ट्रेन मॉडल बेचारा स्ट्रगल कर रहा है. अभी तक सक्सेस तो मेरे को मिली ही नहीं. आई हैवंट गॉट द सक्सेस सो फार इन दिस प्रोजेक्ट. देन गॉसियन नॉइस, इसको इंट्रोड्यूस करा. ठीक है. एंड देन रेस्ट इज ग्लोबल एवरेज एंड दिस दिस, बाकी सब ठीक है वैसे ही है. नॉइस इंट्रोड्यूस करा मैंने. फिर सोचा शायद कुछ हो जाए. देन अगेन आई ट्रेंड माई मॉडल. अनफॉर्चुनेटली जस्ट इंक्रीज 5150, only 5150. So this model also struggled. तो ऐसा नहीं है कि सर आप हमें सीधा सीधा बता दोगे कोड और ये कह दोगे कि हाँ भाई देखो प्रोजेक्ट इज ओवर, यू विल शो अस द कोड डायरेक्ट वन एंड. नहीं, ऐसा नहीं है. I also did tried lot of architectures here where so far you have seen the issues which I faced. The four architectures which I shown you so far, in every architecture I failed. उसके बाद I took exception. ये इंसेप्शन से बड़ा वाला है. ठीक है. That means
Sir,
yeah, please say.
I'm having a hard time understanding going back and forth between English,
हाँ, yes sir,
and
yes sir.
I'm not clear what the difference between the B3
हाँ.
was versus B1 and why you would add noise.
Sir, these architectures B0, B1, B2, B3 up to B7, these are according to the layers present in the architectures. That's what we use: lightweight, average, and heavyweight architectures. Sir, you were there in my live project session for YOLO 11, and I have shown
Yes.
you there we do have nano, we do
Yes.
have medium, we do
Understood.
have large, and we have extra large. So
Correct.
similarly,
Okay.
sir, these are the ranges of the architectures. Depending
I see.
upon
Okay.
their weight, training, and everything, their layers. Okay, that's what we are having.
Okay.
So, sir, I took
Okay.
B0, that is the basic model, the smallest model, lightweight model. Then I took average one also for
Okay.
that, and then I checked. Sir, so far I was facing a difficulty. I'm not improving anywhere because I just stuck here in 40 50. So I thought that there might be a struggle because of the noise present in the data, which is, or like no outliers or something like that. So I think I just tried from mine. It's just an experimentation from my side so
Okay.
far.
What does Gaussian noise do? Does it add noise or remove noise?
Okay, now that's a good question. Gaussian noise is going to add or remove the noise. I am adding this layer, sir. See, add Gaussian noise. Okay, I'm adding this layer. So Gaussian is a distribution, sir. No, no, Gaussian.
Yeah.
Gaussian is a distribution. Okay, fine. That is what we say under root of square root 2 pi sigma e ki power minus x minus nu ka square upon 2 sigma square. This is Gaussian. So this kind of distribution, is it present in my images, present in my image, or I am adding such noise in an image if it is not there? Yes,
You're adding.
we are adding. Okay, if I add such noise, okay, here let's get back here. If I'm adding a noise in the data, does it help me in identifying the features present in it? Will it do?
It should make it more difficult.
It will make more difficult by adding the noise.
Right.
So our idea should have to reduce the noise, not to increase the noise, isn't it?
Yep.
Isn't it or not? Okay, fine. See, the logic here is I'm adding the noise. I'm adding some portion of the noise. The only reason for adding a noise here is I want to make the things to be much more look real. Okay. Just to, in case, because the question has been asked, see, Gaussian noise is for digital images. Okay, digital, like digital na, 0 1. There this such there this noise will be added or something removed, so something like that. Okay, however, the Gaussian noise is added to the images to have some real tendency in it, because Gaussian distribution is our standard distribution, and we are going to add some continuous values to it, continuous values to it, to have some mix up.
Yeah.
Yes, you are absolutely right, sir. There is a increase in the but sir, I want to give a real feel. That means, in case my model is struggling, so maybe it is difficult for my model to understand the pattern. So let me add something from my side, which will be
Understood.
like a Gaussian distribution. So by interpolation or anything, the pattern can be built up. Some smoothing can be added, sir. It tried that can this behavior of the images can be smooth by adding this Gaussian distribution. So some fraction of Gaussian, I think it's 0.25 I took. 0.25.
Mhm.
Some fraction of data points I'm adding into the images. Then I'm trying to capture the features. Okay, I perform average pooling,
Understood.
spatial dimension reduction, then dense layer I took 512 neurons, and I normalized, that means to transform it into a normal format, into some standard, so that there should not be fluctuation in the gradients. Again I added the noise, again I performed the dropout, and again dense layer.
Okay. I have a question then.
Yeah.
So is the idea that you wanna train under a more difficult circumstance to make it
Yes.
harder, and then it learns under that, and then when you do your testing and validation, it does it without adding the noise and with the idea that it'll improve the test and validation?
Yes, that's what I want to do.
Okay.
Because my model is struggling with the test. However, my
Understood.
model is giving good result with training and the validation. That is the issue, na? If you got good answer in training and validation, why your model is struggling in testing? That's the question.
Right.
So
Okay,
let's
thank you.
make things a bit complicated.
I understand.
Okay. So but see the scenario. I trained my model. Here in training only, now the model, it's become much more complicated. Again the same thing, 50%. So testing, I, it says testing per I don't thought to visit. Training only 50%. Okay, nothing happened. Then I took exception model. In exception model, here it is, exception. Exception is again a different architecture, that is advanced of inception. For inception, then exception. So I took this exception architecture. I applied the same funda, Gaussian noise, average pooling, same. Above architecture, above the rest of the component, I took this copy and pasted here. But only the thing is, I changed my pre-trained model. Previously was efficient net. Now is exception. I changed my model, changed the architecture, changed pre-trained. Then I trained my model. Now see, 98 accuracy, training, validation 98. Training and validation both are tip to tip. Sir, let me tell everyone that it is a matter of skills. It is a matter of learning. You guys are live with me right now. You're asking the question to me. Everything is live. Okay, and this is what all I experimented. I never say that, okay, I am done with everything and I'm 100% perfect. No. So far, I have shown you the failures. I haven't shown you the success in one go itself. If I haven't shown you the success, then there is no learning at all. Failures will help in learning. So I failed with these many architectures. Then I tried exception. One new thing which we came to know is we can add noise also in the data. Why? The reason I gave. Okay. So this is the scores I'm getting with training and the validation. I made a plot, training accuracy increase, validation also increase, losses decrease for both. Then prediction, confusion metrics. I got success. See, exception played the game. Now see, 444 true positive, only 4 are false. Here 9 are false, 439 are true negative. This is my classification report. 99% accuracy. I got success with exception. My all architecture failed, but exception architecture, again, that was a very simple architecture. I just took exception, I added few layers, global average pooling, Gaussian noise, batch normalization, dropout, just to prevent overfitting also, and just to give a model experience some outside data to have some good learning in form of a noise. So training 98, validation 98, testing 99. This is successful architecture. I got it here. Then I thought that okay, let's try one more residual net, ResNet 50. Again a pre-trained model. I tried with the same architecture. And remember, I'm working with 224, okay, color mode. And this is with ResNet 50. With ResNet 50, okay, some improvements till 65, but not more than that. And there is a struggle also. There is a but struggle also here with the model, inaccuracy, and the loss. So I think ResNet 50 is also not a valid model to use here. So I use 6 to 7 models here. Yes, yes, ma'am.
Uh, Sir, here, what is actually the thing that decides this success on these pre-trained models?
Uh,
Actually, each pre-trained model will be trained on certain set of images, right?
yes.
So is it the type of images that is got trained on this model or the architecture?
See, ma'am, there are the things which I also told previously. These pre-trained models, I told, they are being potentially trained on ImageNet data. So they have a knowledge about this data set. Now you want to utilize that knowledge on your data set, which is of medical, which these weights are not applicable, or they don't know about this medical. So what I told that okay, you guys know about images, because such kind of questions asked in Viva, that okay, you are using pre-trained model are not for medical, whether they are used for this particular case. Yes, we do use.
Okay.
Okay, for brain tumor, for breast cancer, chest x-ray, pneumonia detection, here I'm using for bone fracture. So they know about images, they have an idea. I'm trying to utilize their knowledge, because if not, okay, I may be developing my own CNN architecture. So these are also no these pre-trained models are also CNN architecture.
Yeah.
And if not, I will also prepare my CNN architecture. So why shouldn't I use pre-trained and do some adjustment? Let's see what happens. That's what I did.
Yes, sir.
And in one of the pre-trained, I got the result. Rest was struggling. One, I got the result. And this is all about skills. As much as you learn, you will get a architecture. However, it's hours and hours and hours of practice, and I know that how in this 1 hour I shown you the few points where I struggled, but literally I struggled a lot. You will not get this code anywhere. No one will try 6 to 7 architectures for any kind of result, and why and what happened. But with exception, I got this result, and then I thought, okay, fine, done. Okay, and after getting also, I tried with ResNet 50. And ResNet 50 again I failed. Okay, there is a struggle with ResNet 50. Okay, it is misclassifying. Okay,
Okay.
exception made exception, yes. That's what it did.
I I had a question.
Yes, yes, sir.
So for the exception now, I suppose what we might be able to do on our own is to go back and then actually look and see whether RGB makes a difference on exception, or adding the noise makes a difference.
Yes, sir. We can go back and do this thing, sir. The point exception, I told pre-trained models do work on color.
I see.
Yes, sir. Pre-trained models, they do work upon color. So ultimately, I need to convert my images, the grayscale images, into color. Then only, sir, I can utilize this pre-trained. That's what something I have seen in the pre-trained models. Okay, because pre-trained
Yeah.
models are trained on ImageNet, and ImageNet, sir, there are many classes, and obviously we are not taking their grayscale images for many classes. Obviously, we have to take the color images. So this change in the color, okay, that is one thing. Just to match the requirement, color,
Yeah.
just to match the requirement, sir. Just to match. What helped is the architecture, sir.
Yeah, I understand. We might be able to. So are you saying that it won't operate on one channel?
Huh, it
Like
will
it
not
won't
operate.
operate on just the green channel
Yes.
or red channel,
Not only a
right?
single channel, it needs three channels to operate.
Three channels.
Yes,
Okay.
requirement.
So and another thing, we should be able to display each channel separately. We should be able
Yes, yes, sir.
to show an image of green, red, and
Yes,
blue,
yes,
right?
yes,
Just as an example.
yes. Green, red, and blue.
Okay.
Separate.
And then I'll do this on my own, but so you don't have to do it. But I'm just wondering what your thoughts are on, if you ran that exception model without the noise, do you expect it would be different?
Yeah, maybe. If I don't consider the noise, okay, and so that's what I think. It's something you guys can try, that
Yeah.
if we are not using the noise here, okay, you can remove this noise from the two. Okay, and you can continue with the batch normalization with the dropout to avoid the overfitting in the model. We can do
Yeah.
that. Okay, just remove the noise and then see
Yeah.
is there any improvement. So we'll get a check for the noise, whether it is
I
helping or not.
suppose there'll be a point where you might get some improvement, but then it'll start to get worse.
Yes, sir, definitely. That's a good suggestion. We'll get the improvements. We'll get some suggestion related to it, whether this noise typically helped or it wouldn't, or the architecture of exception itself is doing the task. Because in I have seen in medical data, you can't claim that okay, this architecture is enough for breast cancer also, for brain tumor also, for chest x-ray also. No, 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 not at all. You can't claim. Different data, different architecture. Who knows on on what you are going to get the success. So that's what we can try. Okay, so okay, just the few things which I want to catch up here is, I think everyone should go through the pre-trained architecture. Here I just took a name: exception, resonate, efficient in it. I just took a name, but you have to go through these architectures, and you can refer to this website, that is Open Genus. Okay, Open Genus. Okay, here the small articles are present. You can search on Google Open Genus and you can write the architect pre-trained model name. You will get it. You get the information. Architectures are present here. They will explain in short. Okay, fine. And every layer information also you will get. For what purpose this is used, for what purpose this is used, we can have an idea. Okay, fine, fine. Let me stop presenting. So, did you find